introduce our next speaker. Rose Schooler is General Manager of the Communications Infrastructure Division with Intel's Intelligent Systems Group. Her team is responsible for delivering Intel architecture solutions for application, control, packet, and signal processing within the communications market segment. So please welcome Ms. Rose Schooler.
Thank you for the opportunity to be here today. I'm excited to talk to you about what I believe is really a transformational opportunity on how we build networks for scale. And you're probably sitting there thinking, you know, Intel's a PC company. What are you here talking about networks, our networks? And I'm going to use the phraseology, our networks. Well, a couple of years ago, the service providers engaged Intel. And you probably think, well, of course they engaged Intel. They wanted to bend your ear about WiMAX. Actually, the topic wasn't about WiMAX and connectivity. It was about how do we leverage and utilize compute technology within the infrastructure. So I was thinking about the questions that they were asking, and I started to look through a comparison about the pace of innovation relative to scale. Scaling out capability, scaling networks, scaling compute. And I looked at communications and I did some research, and you know, the very first speaking telegraph appeared in 1844. We had an electronic switch that followed in the 70s. We had our first service on our networks with caller ID in the 90s. And then we had the iPhone in 2007, and we don't need to talk about what it did to the networks in terms of data and in terms of signaling traffic. Then I looked at communications and I saw the first computer. We always think about the ENIAC, the tube computer, but the first was actually the Z1 in 36, was followed by the ENIAC. We had our first microprocessor in the 70s. DOS appeared in 81. And then we came to the internet age in the 90s, 1984 with the introduction of Netscape. Data centers began to emerge, which is actually a key transition that I'll refer to shortly. And then the evolution of the devices to thin and light, powerful, connected. And someone said earlier, you know, if it has energy to it, it can be connected. All of our devices are connected today. That evolution in communications took 163 years to occur. The evolution for scale and computing took 75. So are we truly leveraging compute technologies to solve some of the network scale challenges that we have today? So to get a little peek into the issues that are facing our networks, let's run a short video to see what happens in a network in one short minute. pretty overwhelming. And I would challenge anybody in this audience to say 5 years ago, 10 years ago, you could have predicted any of these trends. The capacity requirements, the connectivity requirements, and the intelligence required in our networks is not predictable. We need to rethink how we're rolling out networks to support this type of load that they're going to experience. Not to mention some of the security threats that you saw in the video. We're just at the beginning of this evolution. Global traffic is continuing to increase. You heard KDDI talk about it. You heard TJ from Verizon talk about it. We're at a population in the world right now of about 7 billion. We see a forecast of 15 billion connected devices. And James Carlini from Intelligent Infrastructure would tell you, if you're not planning today for a gig to each user, you're shooting behind the duck. The demands are very obvious today, and we have to build a network that scales. We have a case for change. We have to address the change so we can right-size the traditional business models. There's not a carrier on the planet today that wouldn't support a message around, I see my revenue increasing, but I also see the cost that it's going to take to build these networks to support this traffic and to make them secure and to make them manageable. This is our opportunity for transformational change. I'm not here today to provide you every single detail and every single implementation requirement. I'm here to offer you a different perspective. One from the worldview through the lens of a computing company. One where open platforms are built such that innovation can occur. I want to remind you of one key point. Market segment share is won or lost during times of transition and times of transformational change. I believe we're facing one of those right now. But before we talk about how we can build these networks, let's look at the simple demand and supply equation. We'll look at demand first, and we'll hit this pretty quickly, because I think this horse has been beat pretty hard, probably over the last 3 days, but you've seen a lot of data, whether it be in the video or within the other key notes that occurred this morning. Smartphones, pervasive computing, intelligent connected systems. We've seen the examples on the consumer devices. TJ shared some examples from the connected car, from utilities. But we've also seen examples on animals, fish hatcheries. I was at Mobile World Congress 2 years ago at the Ericsson NDA suite, and I don't think they'd have an issue me telling this story. There was a tree that they had connected, and if you walked up and touched the leaves of the tree, it would send you text messages to your phone. It would tell you, I feel happy today, thank you for the attention. It would send messages about, am I getting enough water, I'm thirsty. And that might be a fun kind of demo for Mobile World Congress. But we're seeing real live examples in industry where we're connecting more than just people. We're connecting machines. Those machines are creating business intelligence that can be used then by industry to make better decisions on investments, or in the example of the fish hatchery, is the temperature of the water good for my fish? Is there enough food supply? All of these are excellent examples on how the demand equation, beyond just the consumer, is going to continue to grow. Mobile social networking is exploding. It's the key driver of infrastructure growth in Latin America. We see video consuming 40% of our bandwidth today, growing easily to 90%, especially when you look at some of the examples in the public utilities. M2M, as I just discussed, because not only do we have to connect, we have to send data. It might not be video in all cases. It might be small, but it's going to require network traffic. It's going to require security, and you're going to have to manage those devices. Deutsche Telekom just announced that they expect a 500% increase in their fixed line traffic and a 6,000% increase in their mobile data. We need more standard platforms for innovation. So you perk up, you pay really close attention to the next comment that's going to come out of someone's mouth. And the next comment was, yeah, there were these new processors that were launched called Westmere. And Westmere has an AES instruction. And now that I know that that instruction set is going to be in every CPU moving forward, I have a platform for which to base my security innovation. We need more capability like that. It is a perfect example on how the compute world can take a step towards the comms world, and the comms world can take a step towards the computing world, and collaborate to understand what those needs are, what those instruction sets are, what those capabilities are, to help fight the security challenges. What are security challenges in terms of an impact to a service provider? If there's an attack, it's made known public, it is definitely an impact on revenue. If there's equipment that needs to have to be deployed, there's an impact to cost. We want to prevent those actions from happening, and we want to collaborate in a way that allows us to do so. Virtualization, another key technology that's available within a number of different platforms and capabilities. We think about how access networks are rolled out today. And you're in China, it's a very dense population, and you know that when everybody rides to work in the morning, that the traffic on the network is exceptionally high. You know that when everybody comes home at the end of the day, the traffic on the network is exceptionally high. You have to provision bandwidth and capacity to meet those workloads and those requirements, your peak demand. You have no ability today to manage the capacity and provision based on the average requirements. Leveraging technologies like virtualization allows us to build networks not to peak demand, but to average demand. And by doing so, obviously save cost and deployment, save money. Absolutely is a capability that we want to use and leverage into the industry, using things like virtualization. Standards. I was in a conversation yesterday, we were talking about something simple as a CIPRI interface. How do we support a CIPRI interface? And then someone in the room said, why don't we run CIPRI all the way from the base station back into your head-end unit or back into your cloud RAM? Why can't we use standard technologies like Ethernet to run that traffic? Run a CIPRI protocol over an Ethernet physical. The connectivity cost for making that decision impacts the deployment significantly. Ethernet is pennies compared to the cost of CIPRI. Are we driving enough in standards forums to begin leveraging those types of technologies and taking advantage of things that exist in the industry today versus doing custom proprietary solutions? If we do then, in fact, have a common platform, a known good platform that provides power management, virtualization, a known security capability, on a known trusted hardware configuration, you have then now a common platform for innovation that allows you to do one thing: realize the vision of the software-defined network. In the Open Networking Forum last week, Verizon made a very, very bold move. They stepped forward in that forum and publicly stated to all attendees, our next network will be deployed on commercially available off-the-shelf solutions. We will use COTS-based solutions for our next generation network. How do we do that? We create a common known good platform, we allow innovation via software on top of that, and we define nodes based on software, not proprietary hardware build-outs. So let's take a look at our access example at even a finer level of granularity. We talked a couple times today about HetNet. So I'm glad to see a lot of momentum build up around this concept of having big cells doing the majority of our coverage and small cells fill those gaps where we have gaps in capacity or gaps in coverage. But again, do we continue to use traditional methods and means, or we do something different? Can we use a standard platform that allows us to deploy these networks and not only make a seamless user experience exist, but also provide scale? Scale for software implementations, scale for new services, and build more intelligence out to the edge of the network. I'm sure KDDI or Verizon would much prefer to keep that video traffic that they know is going to create a demand on their networks as close to the user as possible. Do you not want to have the intelligence out close to the user? So if my kid comes home from the soccer game and they really are excited about downloading the Angry Orange video in YouTube, and all the kids in the neighborhood happen to be downloading Angry Orange, don't you want to have the intelligence to know, I don't need to go all the way back into the core of my network to access that data. I'm going to cache it at the edge. I'm going to have that deep packet inspection to know that that's what my consumers are looking for, and I'm going to put the intelligence in my network to do so. Keep the intelligence at the edge of the network. So we definitely have initiatives in this space. About a year ago, or actually about 9 months ago at Mobile World Congress, we had a very public announcement with Korea Telecom and Samsung that talked about the emergence of cloud communications. How do we use cloud technologies? And KDDI even talked about cloud this morning in their presentation to support this big cell idea. We also have a relationship with China Mobile. And we have pilots in place with these service providers today where you just deploy the radio head, not the whole cost of a macro cell, just the radio head. You centralize your processing. You use virtualization, power management to have real-time response to your demand signals versus, again, building to peak demand. Basically deploying a real-time cloud infrastructure. You need an architecture in place in that cloud-based implementation that allows you to respond to the demand and optimize and provision real time to those signals. Then, you also have a common compute platform that allows you to deploy new services immediately into the cloud. You don't have to roll trucks. You don't have to bring blades out to your base stations or your macro base stations like you would today. Our initial pilots indicate that using this approach, if you have a fiber install base, drives 60% savings in deployment costs. That's substantial. What we were shocked to find out is that even if you have to roll fiber, you still get a 30% improvement in your expenses. Save money. A key way that scale will allow us to support the demands that we see in our network today. As I'm presenting right now, and maybe it's not exactly the same time, China Mobile is actually at ITU Telecom in Geneva, discussing their collaboration between China Mobile, Intel, IBM, and Huawei to develop, define, pilot, and deploy this type of cloud-based solution throughout their network. They're going to talk about the demonstration of voice, data services for not only GSM, but also TD-SCDMA, TD-LTE, all on general purpose computing. It can be done. Now that's on the big cell side. There was a question when TJ was presenting about, hey, what's Verizon doing on small cells? Let me show a quick video about a company in the UK that's doing some pretty creative things on the small cell side.
Ubiquiti as a company has been around for about 5.5 years, and our background has been building small and very smart, intelligent cells.
A small cell is a small base station. An intelligent small cell is one that actually thinks for itself.
The thing that's driving the market for small cells is the ever-increasing need of consumers and enterprises for mobile data. We have the ability with this type of architecture to go 1,000 times or 10,000 times as much data.
So the way that our product uses Inteltech is to run in that environment in a way that we couldn't do it otherwise.
Putting two industries together, putting two like-minded companies together, we can do some unbelievably good things to both industries.
Did you see the size of that box, by the way? It wasn't the size of a server. It was a pretty dense solution. definitely the implementation of intelligence at the edge with a small cell. As we showed the savings from an expense perspective on the big cell side, what are we getting in terms of early indication in the deployment of using small cells as a deployment mechanism to help fill those capacity and coverage gaps? We're seeing an estimated 1/4 to 1/6 the investment on the small cell front. Pretty staggering amounts of savings. Again, what are we doing to support scale? We're helping service providers use common platforms across small and big cells. A common platform for innovation, a common user experience, a common platform that allows development of new applications and new services that will apply not only to the small cells, but also to the big cells. We do so in a way that allows the service providers to maintain their quality of service goals. And we know we have challenges in that space right now. I know that when I leave my house and I get off my microcell and I go out to the macro network, my call drops. It's exceptionally aggravating when I'm on a work call and I'm trying to stay engaged in the conversation. Our engagement with the service providers for general purpose computing is not limited to wireless. It's not limited to wireless access. It's pervasive across every node in the network. We will have over time more disclosures of our relationships with these service providers, but I can tell you that there's not a large service provider on the globe that hasn't engaged in the concept of standard, scalable computing capability to help scale their networks for the future demands. So, things are changing very rapidly. I don't think we need to talk about the demand picture anymore. Everybody has seen a million facts along those lines around consumer usage and connected devices and connected machines. The industry is evolving. That is a really good thing, because with every challenge comes opportunity. It's an opportunity to transform how we've done business traditionally. It requires focus. It requires give. It requires that the computing world that I'm here to represent, again, reach across the aisle to the communications world to make sure that the platforms that we're enabling support the quality and reliability requirements, support lifecycle requirements, so the service providers can guarantee that user experience that we've all come to know and love. It requires the communications companies to take a step to the middle, to reach across the aisle, and to start to change and drive adoption of more standard-based solutions, more standard interfaces, more standard platforms, ones that are known such that it enables a capability for innovation. I think back to when I was a kid, and I would walk into the kitchen and I'd grab the phone off the wall to call my girlfriend or my boyfriend, and it'd have that big, long, curly cable that connected the handset to the phone. And I'd sneak around in the dining room to try and have a private conversation. And the biggest challenge then for the network providers in terms of performance was hopefully not having to set up and tear down too many calls at one time and bring down the network. Today, we have a deluge of data, a deluge of connected devices, a challenge around security, a challenge and an opportunity around interactivity of these devices and how we manage and secure and provision them. But in the future, aren't you excited? Aren't you excited about the opportunity that this presents in terms of innovation and new business models? We have an opportunity together, the compute world and the communications world, to truly transform an industry. How many chances like that do you get in your career? I personally am very excited about that. And as I stated earlier, market segment share is won or lost during these transformational times. I asked, do you want to be the disruptor or the disrupted? Do you want to participate in this new ecosystem, in this new value chain? I truly see an opportunity between comms and communications and computing to collaborate and drive this transformational change, creating the software-defined network that we all talk readily about, increasing the pace of innovation, increasing the opportunity to deploy new services, and keeping up and creating a network that aligns with the unprecedented pace that we've seen throughout this conference. I'd like to offer and extend an opportunity to you to collaborate and realize this vision. Thank you.
We probably have time for just one question before we're going to take a short break. If there's anybody with the best question in the entire audience, we want to take. All right, well, what we'll do then is if you can stick around during the break,
Sure.
maybe, and answer questions on more on the one-on-one.
Absolutely.